So our next speaker is Mike Gruver, who has the misfortune to be the only person standing between you and lunch. So Mike is going to, Mike is the Senior Business Development Manager for Chem Aqua. Very interesting bio in terms of the kind of innovations that he's done and particularly the recognitions that he's received for both the inventions that he's done in support of air pollution technology. So Mike, over to you.
All right, very good. I'm taller than most folks, so I got to bring those things up a bit. It's renewed, so let's go have lunch. No, we'll get through this. I thank you very much for allowing me the opportunity to be here today. It's a great privilege to talk about an award-winning technology we have. I'm going to come at it from a little different approach. While we've done a phenomenal job hearing more about modeling, the testing, the sampling, the few slides that I have here about application engineering. Many of you are out there and understand wet air scrubbers that exist out there in the industry. That's what we want to be able to focus on, is the treatment of those odors. What happens out there with many of your customers, or some of those of you that are customers, whether you be asphalt, food, pulp, paper, those areas. The main focus obviously is around wet air scrubber treatment, and then more importantly, a lot of folks will spend time talking about pack towers. We can talk about spray and venturis as well, but the heart of all the data and everything we're going to come behind is around pack towers. Commonly found in the food industry. You'll see some used for H2S remediation in municipalities, pulp, paper, some other areas have those. But that's our application for today. So as we get a baseline of knowledge for everybody, your process gases are always coming in from, come back here. There we go. Your process gases are always coming in from some process stream. And here I happen to have identified it as from your venturi, but somewhere, whether it be a dryer, a cooker, some process, all those fumes, VOCs, the odorous compounds are coming from and through. We always have some recirculating system where in the bottom of this sump is basically just water with your treatment chemical, and it's always in a constant recirculation. The goal is that air passes up through that pack tower system. You're washing back against that airstream with your treated water. The size of those systems may vary upon the needs of your process. The types of odors and gases obviously very much depend on your process. Some key attributes to remember though in managing that wet air scrubber comes down to hydraulic residence time. So how long does that water stay in that sump? More or less, what's my incoming and outgoing water flow? Okay. Very key. What drives that ends up being solubility. Solubility of these VOCs into water, as well as the solubility of your gas treatment stream. One way to help identify some of those is COD measurements, commonly done in wastewater, inlet gas measurements, we had heard many people talk about with their samplings. As well with that, be aware what pH desires or guidances you may have. Many permits may have some pH requirements in them, but again, if you have a lot of hydrogen sulfide, you can run a higher pH and actually just by pH control be able to knock down or reduce that hydrogen sulfide. The same can be inversely said about ammonia. Lower pHs into the 4s and 5s, you can take ammonia and let it become ammonium. Nice water-soluble salt as well. So things to be cognizant of and aware of. And again, it always starts with what's your process gas feeding into that system for you. Okay. We kind of almost had, Luis did such a good job. I don't know if this compares. He had all those nice gases written up so well from his GCMS and other specs. I was going to put it in very basic, simple terms for you, looking at if you always think about your complex coming forward, whether it be a drying application, cooking application, we know that over time things will break down throughout your process, and ultimately what you're concerned about is, again, your organic acids, your ketones, your aldehydes, all of those other VOCs that exist that are odorous to obviously the community. So again, be aware of your substrate, understand how that breaks down so that way you really know what you're treating, again from an application standpoint. What we've been able to do over some time, and as Chem Aqua, while we're a total water solutions provider for air and water, we also sell chlorine dioxide, but realize the world is changing to a sustainable platform. People are interested in how can I do what's right for the community, what's right for my employees, and yet still improve the odor profile as being a good citizen. And for our customers, obviously that's one of the main concerns, is being a good citizen in their communities as well. So what we have taken is over a period of time, over a couple of years, we did GCMS sampling and had a third-party lab actually do the analysis. It was a matter of gathering samples of inlet and outlet gas samples around that air scrubber and looking at that percent reduction of those VOCs. While that list is extremely lengthy and long, we took by functional group and helped categorize it for the sake of a visual aid there. So obviously the mercaptans ultimately encompass a series of mercaptans plus some additional sulfide compounds. So in our aldehydes, there's actually some isobutyric acid, a few of the mild organic acids, a few of the ketones as well, pulled in there from a functional standpoint. And then lastly, our aromatics are basically your benzene ring type compounds. So your toluenes, benzenes, other such molecules that have that benzene ring as the base. So this, again, helps you over time. I tell folks there is no perfect technology. Even, I think earlier someone had mentioned you can look to burn, but you still have some off gas, some odor that's detected from the human nose over a period of time. But again, it's a sustainable solution that can make stepwise improvements for you. Okay. Giving you a brief of what's out there. Traditionally, for decades, probably for over half a century, folks have used, sulfuric 60-balm acid and sodium hypochlorite or bleach. With time and technology, things have moved forward towards chlorine dioxide, sodium permanganate, ozone, other oxidizer-based technologies, where the basic premise is, can I have a chemistry that donates an electron so that I can change that molecule that I'm reacting with in a short period of time? And to give you just a quick pictorial of how those go through, there's just an example. Most aldehydes, when reacted with oxidizers, turn into some sort of organic acid. The principle of most mercaptans when reacting is to get into some sulfite-based molecule, and then a lot of the aromatic ring molecules, actually because they're so stable, don't react, and therefore won't break down, and you have little effect a lot of times. Okay? With that in mind, the premise of the Renew application, and this is a lot of what really grabbed at the United States Environmental Protection Agency and given the award, is that the premise is non-oxidizer. It's a blend of food and pharmaceutical grade enzymes with biodegradable surfactants and some wetting agents. So it's things you could eat. Now, we don't encourage folks to do that, but there are things that are naturally occurring in that respect, so that way it helps fit those molds. The other part of it that jumps out at you is that when you think about my cell formation, all I need is a hydrophilic and lipophilic end. I'm not looking for a specific reaction. I'm not looking for an electron donation to occur or anything of that nature. Okay? All I need is a hydrophilic lipophilic end, and we can actually capture those gases and help bring them into water for further breakdown. So go into a little pictorial to help out with that a bit. Okay? Again, if you think about in these packed air scrubbers where they get tenths of seconds for reaction, and again I have this counterflowing water against an airstream, all we want to be able to do is through my cell formation is think I have this VOC floating up. How can I quickly capture that, pull that into water, or as well with surfactants, you can get a reduction of surface tension. So you get a natural migration as well into water. So again, I'm not waiting on a reaction, I'm allowing a migration to occur. So we want to foster those things to occur in multiple mechanisms instead of depending on just one sole thing to occur. Okay. Another good pictorial, and again, we have to do quite a bit of business in the food industry, pet food, food flavoring, food processing. So a lot of those folks will have cookers or dryers that ultimately end up feeding those systems. But again, it could be applied in many other avenues. If you think about your VOCs coming through from your process, and I get that interaction with water where I can again bring them into the water molecule, allow that to get down in the sump, and from there allow a breakdown to go ahead and occur. So, one of the things that we saw, as you saw that earlier histogram, that helped probably pick up another 6 to 8% reduction in VOCs out of the stack was that reduction in surface tension. The books of surfactants out there are 4 inches thick if you want to go out and look, and so it took us probably a year to find the right packages, you'd say, that can reduce that tension relative to those gas streams we find mostly around in hard industry. And it's amazing how just the simple mechanics and physics of surface reduction made an 6 to 8% gain in reduction of VOC. So, yeah. One of those things that many of you may have seen or experienced a lot of packing out there. People have some program or offline. They're having to do some sort of clean out, whether it be using caustics, caustic cleaners, other avenues. Suspended solids will start to build up if they cycle up. Again, if my hydraulic resonance time is off in my scrubber, I may supersaturate that solution and deposit those suspended solids onto the media inside those pack towers. This happens to be obviously an extreme example for the point of pictures. It actually happens to be a current customer, actually, still even for this date, one of our very first, where a lot of fat, oils, greases, things were super saturated up, built up, residence times not being put in place. But what we've done is by putting a surfactant in our package online, instead of a clean out of those suspended solids on a weekend or monthly basis, it's occurring all the time. So it's an online application. So think about it as CIP, clean in place, instead of versus a clean out of place. And to use that pictorially to think, again, many of your customers or folks you may know, monthly, weekly, at some point have an interval where there's some cleaning process. But with that, they lose efficiency over a period of time. It creates back pressure. They lose operational efficiencies of vacuum pulling through those systems. As anything else, we know the cost of steam, air, electricity feed into total cost of operation. So the need to have a good vacuum that can pull through a whole system at all times because that scrubber is clean actually has operational benefits and cost savings as a whole that help customers, again, improve efficiencies. And everything in the world it seems like it's about efficiencies and productivities. So whatever we can do to help impact that. Over time, a lot of our customers, we'd like to get feedback on what folks say out there in the industry. I'm a biggie on the 360 feedback activities. So after a period of time when they've had the opportunity to become accustomed to how everything is operating, how it's performing, we'd love to gather some feedback. And here's just some customer feedback things that are said out there in the industry. Obviously, we want to be good neighbors. That's why odor profile is always number one. In the United States, the SARA 311 and 313, those are key reportables in the United States that feed into a Tier 2 report upon which a lot of industry has to pay associated fees for, and now you can get ready to eliminate some of those hazards. In California, Prop 65, this is not on the Prop 65 list. That's about carcinogenics, so it ends up being that environmentally sustainable fit. And obviously, like anything else, people can, if you go down the line even further, you think about wastewater. What happens in a scrubber? Where's that water go? To wastewater. Well, why do I have wastewater odors? Probably went back to maybe what happened further up in the plant process. So you can also think about this as a point source reduction for some of the wastewater issues you have by taking care of the scrubbers in a better fashion. So, okay. A couple last things. Annually, what we love to do is talk about that sustainable play. What is the impact to others? What's the impact? I grew up as a farm kid, still go out to the farm. It's amazing how that's changed. I can remember Grandpa out there driving around just randomly spraying stuff, not knowing what was in that spray, to now the regulations around how you apply, how you do things, how even as my brother does the farming now, is concerned about conserving water. I would have never thought my brother, the hog farmer, would be worried about conserving water. Okay? It's the world we live in and how it's continuing to evolve, and we want to make sure that we're evolving with that. So on an annualized basis with our current customer base, we actually help them conserve over 42 million gallons of water. With the growth we're seeing right now, probably for next year, we'll make that over 50, 55. But again, we want to be better stewards to the environment as well as neighbors there. Okay. The other is a list of other things as you think about some of the other hazardous chemicals or traditional oxidizers, things we use every day, but don't realize what negative impact they may have as they get down the stream into wastewater or go further into streams, go onto the cities. So again, as we think about the impact that we can make to our communities, some very, very positive things for that. So, okay. With that being said, you can always see us out at one of the booths, or is there other questions? Feel free to get a hold of us. I know everybody wants to eat, so I appreciate your patience. And with that.
Questions?
Everybody's ready to eat.
Oh, I don't know. Sorry. Thank you very much.
Yeah.
The surfactant.
Yes.
So you eliminate many of these other chemicals, but you've had surfactant in sufficient concentration to create the micelles.
Yep.
Is there any recycling of the surfactant through the process, or is it a continuous feed and loss through the system?
It's a continuous feed. We actually feed on an interval basis and are usually running anywhere from 190 up to 200 parts per million. They have, well, the true act, that's of the product active, more like 70 to 160 part per million. So we actually do concentrates. You'll see that because in a scrubber, water's always coming in, water's always going out. It only cycles up probably about 1.5 cycles compared to boilers, cooling towers, other things people are associated with. So you do have to have that constant feed for replenishment because of that overflow that way.
And are there any environmental considerations or opposition to the use of the surfactants in your account?
We haven't run into those things at this time. The industry as a whole had always been using such harsher chemicals with caustic foaming cleaners, other activities, that the thought of having something that can break down readily into wastewater, a lot of folks through wastewater have seen, a lot of the oxidizers were killing their bacteria that may be in their aerobic systems, and now all of a sudden you actually have an opportunity for the natural flora and fauna to facilitate breakdown not just of these surfactants since they're biodegradable, but then other suspended solids and compounds within our systems. So,
Thank you very much.
thank you.